Without further ado, I want to introduce you to our Chief Solar Engineer, as we call them over here, Josh Weiner, the CEO of SepiSolar.
Thank you, Thor. Everyone, really excited to be here with you to talk about storage. I want to acknowledge some of the staff at SepiSolar for helping get this put on. Thor Valenza, who you just heard from. Also in the background, Richard Dobbins, who is our state licensed electrical engineer, professional engineer. He's got code books in front of him, and we want to go. And the purpose of this is to really go in any direction that's helpful for you. There's a lot of talk about storage and Solar+Storage out in the market, in the media, around trade shows and conferences and webinars like these. So, we, as an engineering firm and a technical consulting firm, we like to go to the source. We like to be accountable and document things that we represent. So we've got all kinds of reference materials, and Richard's our lead designer and senior designer here at SepiSolar, who's done a lot of the nuts and bolts on a lot of these storage systems. So together, I think we're going to have a lot of great material to share, data to talk about, perspectives to offer, and I'm really excited to be here with you. So thanks for joining. And by means of introduction, would like to introduce SepiSolar. For those who don't know much about SepiSolar, we are a design and engineering firm that specializes in solar storage and microgrids. And I think a lot of you on the call will identify, our mission is to transform power with communities of passionate technical experts, subject matter experts, and engineers who really care about solving energy problems for people around the world. That is our mission, and we do it with an eye to technical details and perspective, to help surface sometimes nuanced and technical design and engineering issues to the surface so that our clients and developers and EPCs, installers, and other stakeholders in the integration process around the world get the technical information they need to make the right business decisions for them and their clients. A little about us. I've been in solar and storage actually since 2008. In solar as SepiSolar, as well as in storage, I helped co-found a company called Green Charge Networks. For those of you who are familiar, it was acquired by NG in 2015 or 2016. But SepiSolar is based in Fremont, California, but we do work all over the country. And we work for contractors, EPCs, developers, asset owners, architects, public projects. We have a portfolio of residential projects under our belt, commercial, industrial, and ag, utility scale, including with and without storage, with and without a grid connection. We've seen and done just about everything. Small little log cabin in the woods with solar and storage attached to it with maybe a backup generator, all the way through to utility scale, parallel operated storage for time of use optimization of solar with backup capability for availability purposes on the grid. So all kinds of really interesting use cases and revenue streams come in that we've engaged with, and we'll talk about some of that today. Of some of our founding principles, just the things that we believe here at SepiSolar, that there's a lot of, it's a complex landscape. Energy is not straightforward. And so sometimes having an engineer or a financial engineer who really understands not just horizontally, the breadth and depth, vertical or horizontal and vertical expertise can be very helpful to articulate these systems that can get complex. So bringing those capabilities to the market is at our core, bringing subject matter expertise capabilities. That's what we're all about. And also not just putting drawings together, although that is a core deliverable and a work product that we deliver routinely every single day. Engineers and designers, we speak in pictures and drawings, and that the picture, as they say, a picture speaks 1,000 words. So while it is important to design drawings and systems on paper, I actually think of our role in the value chain as more about understanding requirements. Any project, whether it's 1 kilowatt or 1 megawatt or 1 gigawatt, you're going to have product specifications and product compatibility requirements that need to work together. You're going to have site constraints. You're going to have permitting requirements, utility requirements. If there's a financier involved, you're going to have financing requirements, and all these, requirements have to line up with each other at the end of the day, no matter how big or small the project is. And everybody out there knows you miss one of these requirements, it comes back to bite you somewhere in the process in the form of delays or cost additions. So, the way I think of it, our role is to really help prep and plan the projects and catch all these requirements up front, prevent snowball effects downstream, and get these projects through as quickly and efficiently as possible. And then finally, at SepiSolar, we believe that engineering and technical consulting absolutely go hand in hand. For example, I think engineers make better engineers when they know what the best state-of-the-art, best-in-class technologies, partners, programs, and policies and codes are. That helps guide engineers to make better engineering plan sets or make better engineering and technical decisions. Likewise, engineering informs consulting by telling the consultant what actually works and doesn't work on the ground floor. And so nothing annoys me more than a consultant who's not based in reality or an engineer who solves the wrong problem. They might solve the problem very well, but they don't solve the right problem. And so consulting and engineering have this perfect feedback loop, and we do so much of both in SepiSolar and really leverage both to provide a better all-around service across the board. Some examples, as you may see on your screen, some examples of the kind of work we do. A lot of project engineering work like sales support, pre-design layouts, and we do smell tests from our staff of structural professional engineers and electrical professional engineers. We have a nationwide network of professional engineers in all 50 states with both electrical, structural, and civil engineers. We even have resources for chemical and mechanical when those are needed, when you're in a high corrosive environment or you've got moving parts like trackers. Feasibility analyses, design packages, permit packages, as-built construction sets, value-added designs. I mean, not just putting things on paper, but actually, like I was mentioning before, surfacing requirements, looking for ways to add more value out of your system, because it's a lot easier to make changes on paper than out in the field. So these are the kinds of things we think about in the design and engineering process, and getting through those approvals. On the consulting side, a lot of economic analysis. There's been a lot of interest in storage. That's really what prompted the Ask Me Anything series. I mean, there's been so much talk and so many questions around storage. This is, I hope, a really exciting opportunity for us to ask the tough questions, to get into the weeds, nuts and bolts, and let's surface it. Let's rip it apart, put it back together, and I'm as excited to learn from you as I hope you are from me. So let's. There's a number of things else that we do, territories we serve, markets we serve, deliverables. I'm just flipping through it in front of your screen right now. But please, if you don't know much about us, please feel free to reach out after this call, after this seminar, and we'll share some of our decks and capability and statement of qualifications with you, so you can learn as much as you need to about us. And we look forward to working with you. With that, let me just talk a little about storage. As I mentioned, energy storage is such a hot topic. There's so many markets and applications and technologies and product configurations, and we are an engineering firm, so by all means, feel free to ask technical engineering questions, but also feel free to ask market driver questions, economic use cases, applications. Incentive structures. These are all things that we regularly deal with on a regular basis as part of our standard scope of work. We're looking at these storage and Solar+Storage systems from technical perspectives vertically, as well as broadly, horizontally across markets, like what's addressable with this particular configuration, what's actually a real problem that we're solving with one configuration over another, with one technology over another. So and then how do you quantify that? What's the actual dollar value to somebody? If it don't make dollars, it don't make sense. You've got to be able to convert kilowatt hours and kilowatts to anything that we do with solar and storage. So, as I like to say, I mean, solar does make energy cheap. Batteries make it all the time, and so that's what customers want: cheap energy all the time. You need both solar and storage in your toolbox, and how to articulate those with dollars, with kilowatts and kilowatt hours. So really looking forward to your questions. And with that, why don't we, Tor, open it up and take the first question.
So once again, for those of you who chimed in a little bit late, the way this is going to work is you've either called in or you've dialed in with your speaker through your through your computer. Again, this is a interactive thing, so you get to talk, you get to ask the questions. You can do it also through the chat window, but we don't mind a dialogue. So if you're on the phone, I'm going to start the Q&A, and you're going to get into the queue, you have to dial *6, and if you're dialed in through your computer, you'll see a prompt, and to ask a question, hit that, and once again, we'll go down the line in order, and we'll try to tackle each question that we can. All right. This session is starting now. All right. Get ready. All right. We have one question from Edgar Becerra. All right. Here you go, Edgar. You're going to be on the line. On your phone, I think. Well, no. Yeah, sorry. Edgar, you're live.
What are some of the common inverter sizes for the commercial solar+storage?
Awesome, Edgar. Thank you. Yeah. So you mean in terms of like what's the size of inverter? Like physical size, like kilowatt size?
Kilowatt size.
Yeah. For CNI specifically. Correct. Cool. Yeah, so I've seen anywhere from like string inverters. It doesn't seem that different to me from our perspective from standard solar. So you see there's some philosophies that string inverters are better. So there are definitely a lot of 20, 30, 50 kilowatt size inverters I see, which I would kind of put in the string inverter category. You know, it's you know, something that's wall mounted, or if it's a smaller footprint, you know, can sit right next to the battery often. Also, the larger centralized inverter architectures are out there. So large, like megawatt size inverters. I also see those. So, and then in those cases, the storage could actually sit adjacent to the inverter, or it could be a distance away, depending on the configuration of the storage. So there's these large containerized batteries, right, like ISO container style, and then there's smaller custom enclosure batteries that might be stacked up in series and in parallel to make an array of batteries, and those may gang together into a larger inverter. So I've seen a lot of both. Has that been your experience too, or?
So in the smaller CNI space, 20, 30, and 50 would be reasonable kilowatt groupings. And then in commercial or in larger scale, you're talking 100, 250, and 1 megawatt type.
Yep.
Okay.
Yeah.
Follow-up question. When you're doing PV plus storage, what kind of interconnection requirements, like the 120% rule, are you facing? Are you seeing more AC coupling or DC coupling on the system?
Awesome. Great question. So, yeah, the 120% rule, for those of you for those of you who don't know, the question is around the 120% rule and how does that apply for solar and storage. The 120% rule is like a colloquial phrase that we use to describe, I think it's NEC 705.12D, something like that.
705.12D23B.
Thank you, Richard.
I say that in my sleep every night.
So yeah, the 120% rule is this really cool code that for those of you who don't know, it was almost like the enabler for solar. You know, back in the day, if you wanted to plug solar into a panel, a service panel, most service panels are rated for the size of the max of the service disconnect that feeds it. So, you know, you put a 100 amp panel with a 100 amp breaker on it, for example, in like a residential system, or if it's a commercial system, you know, you might have a 3,000 amp service panel with a 3,000 amp main service disconnect. And without the 120% rule, you couldn't add any solar to that because it's already maxed out. You've got a 200 amp service with 200 amps worth of current attached to it. You're done. You filled it up. But because of this lovely 120% rule that Edgar on the call is mentioning, you can actually put over the rating of the service panel. You can put more energy into that service panel than it's actually rated for. And the logic is its electrons are moving in different directions in that case. There's a difference between sources and loads, and you can think of it differently. And so this 120% rule has been with us for a very long time in solar. How does that play out with storage? And yeah, that is, so the answer is, just like solar, you do need to consider storage as both a generator and as a load. It's really both. You know, solar is just the source. It just supplies. Storage does that, plus it recharges itself. So it is like a load. All the rules apply the same, just like any load and any generator. So it's a little harder to design for storage systems because you have to really design it twice, so to speak. You have to think of it in two ways. And where it gets even more interesting actually are like line side points of connection. So not to go off on a tangent too quickly, but I promise I will do that. For 705.12, for the 120% rule, you do treat it similar to a solar system. You add up the current that's supplied, the maximum discharge current that can be supplied from the battery, and you actually have to add it to the solar. So now you've got the sum of both, and the sum of both cannot exceed 120% of the rating of the bus bars or conductors that they're attaching into, and everything upstream from there as well. Where it gets interesting, and so this will be an issue, right? I mean, we're already maxing out the 120% rule for standalone solar systems. Now we're talking about plugging storage in. So in a way, there's almost like a little competition game here where the solar and the battery are fighting for electrical capacity under this 120% rule. So that is a challenge. And so there's, I'm just going to preempt the next follow-up, but let's say you were trying to follow the 120% rule with solar and storage, and there's more that you want to add that you don't have capacity for with the 120% rule. Some of the workarounds are to decrease the size of the main service breaker. A lot of us are familiar with that method. It's often accompanied by load calculations, often stamped or sealed by a licensed electrical engineer. And by the way the code, Article 220, directs the designer to do those load calculations, there can be quite a lot of license in there. You know, if you have a controllable asset like a storage system or a load controller or an energy management system, there are ways to manage your load differently, dynamically. And so your load calculations can absolutely take that into account. And it would be completely understandable if somebody didn't want to take a designer's word for it. They wanted, some engineer with a license to stand behind it. So getting the design right and getting the, if you will, the liability or the insurance and the that extra layer of safety and protection assurances around it, that's all things that you may need to come across to be able to get the design and engineering through permitting or utility interconnection. So load calculations definitely get more nuanced and more creative. They can get more creative within reason, of course. And then and verification along with that as well, making sure whatever is being designed, that the product can meet those requirements. So making sure to work with the developer, with the EPC, with the manufacturer, and making sure all this stuff lines up at the end of the day is really critical. Also, you can go on the line side point of connection. So for those of you, when you just simply can't meet the 120% rule, you can't create enough load calculations, you can't derate the main breaker enough, you can't, for whatever reason, upsize or upgrade the bus bars or the service panel itself. You can always get around it with what we know is what some call a supply side point of connection, which is where you bypass the panel entirely. You connect the solar, the storage asset, on the line side of the disconnecting and overcurrent protection means for that service panel or distribution panel. And so in that case, you follow the rules of line side points of connection, and there is an exception for line side or supply side points of connection for storage. That again, solar, it was a bit more straightforward because it was just a source, just a supply source. But with storage, it is a load and a supply source, and so it is very prudent and important to treat that battery as a load, especially if you're going around the main breaker and you're doing a supply side point of connection. You are now, there's much more pressure to get the engineering right in that situation. Those connections are not always straightforward, and you do run the possibility of overloading feeders at that point. You have no overcurrent protection in between you and the grid, potentially. So doing supply-side points of connection with solar and storage is a tricky but important thing to focus on, too.
All right, let's go to the next question. Thanks, Edgar. If you have other questions down the line and there's nobody else in the queue, then please chime in again. Here we're going on to the next person. Hey there, you're on the air with Josh Weiner.
Yeah, hi, can you hear me?
Yep. Who's calling?
Great. This is Ken Bradley with Oxbow Sunworks out of Minnesota.
Cool. Welcome, Ken.
And so I have a fairly simplistic question, but I think one I'm interested in your insight. Of segment customers kind of in the commercial segment, who would you think are the customers that would benefit the most from solar/storage, and who are the customers that probably it's just not ready for prime time yet?
Yeah. The great question. There's a lot of customers out there. So for storage, so the answer is customers that have appliances or equipment that turn on and off frequently, and the definition of frequently can vary by tariff rate, by location and solar irradiance and things like that. That is usually an indicator that storage can do marvels for their demand reduction capability. And then, of course, and then that's storage alone. When you add solar to the equation, solar plus storage, it can be that, stuff that turns off and on. It could also be constraints on the grid for interconnecting more solar. We're seeing a lot more of that than we ever used to, where folks are trying to get utility interconnection applications approved, but for whatever reason they're running into problems, and it's usually related to a local capacity constraint. There's only so much solar the grid can take, and it's region dependent. It's locally restrained. So storage becomes a great enabler for solar in those types of regions. And then finally, like San Diego, for example, and soon the rest of California, as rates shift, peak time of use rates shift away from the time that solar is generating into the, say, evenings because of the stuck curve issue, we'll see that being a major driver. So any customer who needs solar but can't make it pencil because the rates aren't good enough, that's a key indicator that that's a good customer. So who are those customers? I mean, they could be large industrial manufacturing processing facilities, like cold storage or process manufacturing with big machines with big motors. They could be 70 horsepower motors that turn on and off. I'm thinking of print shops or condensers, compressors, anything with a motor. In fact, that's the most clear-cut case. Then you also see customers who are more like office buildings or grocery stores that might be one and they have a more constant load. Ironically, those customers can work really well for solar plus storage, which might be counterintuitive because you think of demand reduction as needing spiky loads. But when you put solar on a demand profile that's relatively flat, if you can envision in your head, in your mind's eye, a very flat demand profile customer year-round or all day long, solar will dip into the high peak of the afternoon. So like from, say, 9 to 3, you'll see this big chunk of demand get consumed by the solar, and you're left with I've heard this phrase used and I kind of like it, like two devil's horns on the side of the solar generation curve. So you'll see like a peak in the morning and a peak in the afternoon because you've just dipped. With solar, you've taken the middle out. So you have these like two humps in the early morning and the late afternoon. That becomes your new constraint. You've solved the energy problem with solar, or you've gone as far as you can with it, but now you have these two big humps, and the fraction of the demand charges on your bill go up to like 50% or more of your total bill is going to demand charges. So solar sort of solves one problem and creates another, and then you add batteries, and it solves the rest of the problem. So customers who need solar make good battery customers. Customers who have constraints with the grid, and then, of course, customers with peaky demands with stuff that turns on and off are all great storage and Solar+Storage customers.
Okay. Does that answer your question, Ken?
Yeah, that does. Thank you.
All right. We're going to move on to Ms. Raina Russo, who is another social media friend of mine on Twitter. So going to you next, Raina. Here we go. Raina, you should be on.
Hi, my name is AJ. I don't know if someone else is supposed to be on, but
sorry, AJ. It looks like yeah, but actually, Raina asked her question through the chat. So can you hold on for 1 second, and we'll get back to you?
Sure.
Okay. So Raina asked, what type of storage is available and viable for the Florida residential and commercial market? Which brands, and also does storage benefit from the ITC credit if installed in conjunction with solar?
Yeah, there's so many brands out now for residential and C&I storage. A great way, by the way, to see a list of a lot of those companies. A great resource that might be helpful is the California Energy Storage. So feel free to visa and check out their member lists. They've got all kinds of people, storage manufacturers, integrators, but they range from companies like Sharp and LG, and of course Tesla, all the way to, you've got contract manufacturers like Flex, and you have large developers like AES and Advanced Microgrid Solutions, AMS. There's a long list of brands and names out there for sure. And then, of course, the next question, usually for us as designers and engineers, is which is the best? Who do we work with for this particular specific project? Because I am learning that storage is not a one-size-fits-all. It sort of is with solar, right? A lot of projects use silicon. Silicon sort of won, with one obvious glaring exception being First Solar. So there's always an exception, but I think storage will play out a little differently. There can be many answers to that question depending on the use case. And in a way, storage is a little like bacon. It works with everything, and that's its strength, but it's also a weakness. You lose market focus. So picking the right partner for the right application is very critical, and I would encourage talk to these companies, learn about their products and their system configurations, and make sure when you encounter a specific project, you pick the right one or the best. Question about is a pretty straightforward one. We just had the IRS issue a memo relatively recently, publicly stating that. So actually, sorry, let me back up. So yes, when you install storage with a renewable generator, that storage device qualifies for the 30% ITC. Now there is a cliff, there is a requirement. You have to supply at least 70% of the electrons going into the battery. At least 75% must come from a renewable source like solar or wind. So as long as you meet that criteria, you can get the tax credit. And it is prorated, so you actually need to charge the battery 100% from a renewable source in order to get the full 30% ITC tax credit. So actually the only way to get the full 30% tax credit is to only charge it, to restrict the battery to only charge from solar or wind. And then where it gets interesting is what about retrofits? And this is more recent. This came out, I think, late last year or early this year, maybe, where the IRS came out very clearly for retrofit projects. If you have an existing solar system, you can now retrofit that existing solar system with storage, and you qualify for the 30% ITC for the storage as well. So that was a huge win for the storage industry at large, and for developers and folks who are implementing these systems. There is absolutely, if you hook solar up to it, and if you put systems in place to require the battery to only charge from this renewable source, you can get that full 30% tax credit, whether it's a retrofit or a new installation.
Okay, Thanks, Raina. Let's go down to AJ, who's already on the line because we had a technical difficulty. AJ, you're on.
Hey guys, this is AJ from Emerscope. Quick question I had: what have you guys seen as it relates to O&M requirements for lithium-ion batteries in the C&I space? Are there, is there maintenance required on a yearly basis, or is it a bi-yearly? What kind of components need to be serviced? What kind of components need to be replaced? Just wanted to get a better idea from you guys on if you have any input on that.
Definitely, yeah, great question. I mean, understanding capital costs is like the first step, but figuring out these operating costs over time is always the hard part. It's how many of these systems are actually running in the real world, and how much uptime have they had, and what failures have we seen, and how they've been fixed, and how publicly available is that data. Very, very tough question to solve without having done it over and over again. Which is the answer is for lithium. So the obvious answer is it depends. Different storage products and technologies have different levels of maintenance involved. What is very common across the board, though, there's always some type of thermal management system involved with storage. These things need to stay cool, either for operations or in the case of lithium for just pure safety. You can't let them get too hot for safety reasons. So for all those reasons, thermal management like HVAC, cooling fans, convection fans, if it's liquid cooled, which is out there, having the right pumps and motors working and pumping fluids and leaks, doing like system inspections. I almost think of it like your car, right? Like batteries are sort of becoming like a car. If you do some very light maintenance all the time, keep an eye on it, make sure there's no leaks, make sure thermal management is working, make sure your software and your connections are made and communications and controls are going back and forth and the system's making money and all those things look good. It'll last a very long time. And then you might have more, sort of like a car, minor and major services. So minor services on an annual basis might just be swapping a filter out on an inverter, for example, if you're in a more dusty environment. It might just be spot checking the HVAC, and if you can do that remotely or on-site, however that works, there will be different costs involved depending on the data acquisition and management. And then you'll have more major service, like, for example, you may have to replace the air conditioner after a certain amount of time. Those things do wear out, or they get less and less efficient to the point where they're just not economical anymore. And this is actually kind of a point of study at SepiSolar. We're trying to understand things like round-trip efficiency. And a lot of folks quote efficiency at the cell level, not the system level, or they only include the coulombic efficiency of the battery itself, not all the series and parallel connections between packs, and not to mention the HVAC, the thermal management, the auxiliary loads. All that can factor into round-trip efficiency. And all those numbers change over time. Air conditioners get less efficient over time. So round-trip efficiency is not a constant, and it is a nuanced characteristic to dig into. So major O&M might be like swapping out, like I mentioned, swapping out the HVAC. It could even, depending on how you define O&M, it could be replacing, in the case of lithium, it could be replacing the batteries or augmenting them. And there's different augmentation strategies. And whether you call that a capital improvement or an operating cost, somewhere that does need to be captured. That is money going into the project to extend the life of these batteries. And there's different strategies, different costs and benefits associated with that. So that's if I were to put them in broader categories, it would be thermal. O&M happens at the thermal management level, at the software level, like controllers, communications, and controls. Those all need to be working and being updated. If you're on the customer side of the meter, demand tariff rates do change and rates change. So making sure you're always optimizing your system for the rate you're on or the rate you should be on, could be regular maintenance. As well as the augmentation strategies and system inspections and checking and leaks and pumps and things like that.
How's that, AJ?
Great, thanks. That's definitely helpful to know. I guess I was just wondering whether you have any input on whether these things, is there like a fixed duration for these? Is it something that can be done, every couple of years, or every year, or is there, what
Yeah.
have you guys typically seen when it comes to your customers that you work with and their O&M requirements?
Yeah. Commercially, what I've seen, some people only maintain the battery when you need it, so you don't have to buy an O&M package with your battery if you don't want to. And then when something breaks, you pay as a service. So that's sort of like buying a car with a warranty, with the service package, or so you can buy the battery with the service package or without. And there are different terms for that package. They could be a 5-year package in California, for example. If you want to get SGIPs and rebates, you do need to have a 10-year package. And there could be, and I've seen longer. There are batteries that can go out to 15 years and 20 years now that are commercially available. That's a big leap forward that is very recent. The technology is not new, but the commercial wrapping around these technologies is new, and they are being proven out today. So you can get basically warranties from the manufacturer, from the integrator, that can be for only scheduled maintenance or scheduled or unscheduled maintenance in case something breaks. That's sort of like a warranty with a guarantee attached to it. Some people guarantee or warranty the parts and labor. Some people warranty the availability of the battery, which is, in my head, a little stronger, right? Like, who cares if the nuts and bolts are working? I want that system generating the value I paid for. So whether the nuts and bolts are working is one layer of protection, but really making sure you're extracting the value in the form of a performance guarantee or capacity guarantee or availability guarantee. Those are all different guarantees I'm seeing in the market, and it's kind of a free-for-all. There's so many. I haven't seen a market standard for that yet. Like, it's traditionally, or in my experience, it is a bit all over the place. I've seen a lot of different warranties, and it's technology. It's technology contingent or dependent because, for example, there are batteries that degrade and there are batteries that don't degrade. So the batteries that do degrade, it is very important to understand how they degrade and all the modes of degradation, and how do you warrant all those different modes or all of them together. It can be like an engineering puzzle. I've seen engineers pull out logarithms, derivatives to actually calculate these warranty periods. It can get that complicated. And then you have the batteries that don't degrade or degrade extremely slowly, and the manufacturer is more comfortable putting something like you see on a solar panel. If the performance guarantees or the warranties on the spec sheets of a solar panel show like a very clean step down ramp rate of what's actually the performance that's being guaranteed or warranted. So more sophisticated manufacturers will have more information available for guys like us to analyze.
Okay, Ron.
Great. Thank you.
Thank you.
Sure.
All right. We're going to move on now to a question from Ron, who asked, is there an unbiased, accurate chart from an independent testing lab of expected life cycles of all the battery brands? I think we do know of one, don't we? The Australian report.
Sorry, could you repeat the question?
Is there an unbiased, accurate chart from an independent testing lab of expected life cycles?
Yeah.
Yeah.
Great question. Actually, I'm going to go to my screen for this because there's going to be a great website I want to turn people onto that's proven helpful for me. So the answer is yes, but not a lot, not nearly enough. There are really only 2 companies I'm aware of that are doing this in a public way, and one of them is Nextracker, who's a client of SepiSolar's. We work with them because they are interested in. What's interesting about them is they're not a battery company, but they are integrating batteries into their supply chain and into their product portfolio. And they are sharing this information. If you're members of CISA or CALSA, they're all members of these trade organizations, and they're sharing this data very openly. I've spent a lot of my career trying to get data from battery guys, and it is not always straightforward. That data is coveted and it's valuable. So it is very challenging to get. But companies like Nextracker are publishing this data. So I would encourage you to get in touch with them, learn about their storage, ask them about their data, and they will provide it perhaps with or without an NDA, I'm not sure. But they are testing a variety of batteries across technologies at the same site to the same demand profile, and seeing how they compare with each other. It seems like a simple question, like, and then the other one is on the screen right now, batterytestcenter.com.au. This is a really cool test lab that is put on by ITP Renewables. They are funded by ARENA grant, which is an Australia grant, and they're using their money to test batteries to see what their life cycles are, what their degradation rates are, how round-trip efficiency degrades over time. And there's some really cool reports, actually some that just came out very recently. They have all these batteries side by side with data available, and you can flip through them like I'm doing right here. You know, you see Simplify, and I would encourage. There's real-time data here coming right through the web. There's also reports that you can download that are more comprehensive. They go back and they talk about the history. Because here on the web you can only see a real-time snapshot, but if you want to see the cumulative performance over time, I would definitely encourage reading those reports. They're very valuable, and I'm so grateful that companies like this are doing that. It's all too rare to get publicly available data on batteries, so that is definitely a challenge, but companies like these are tackling it. And there's definitely batteries that Nextracker is testing that are not on this list, and there are batteries on this list with ITP that are not at Nextracker. So those are two off the top of my head that are available today. And the data is very encouraging and interesting and validating. What they're doing, and this is really important, it's a simple question, but what both of these companies are doing that nobody else is you know, if you talk to any manufacturer and ask how their battery degrades over time, they'll tell you, yeah, we cycled our battery up and down 10,000 times a year at this temperature, at this depth of discharge range, at this average state of charge, and it degrades at this rate. Great battery, buy our battery. Then you talk to another manufacturer who says, yeah, we cycle our battery up and down 5 times a year at this temperature, at this other depth of discharge, at this other testing protocol, and our battery degrades really slowly. Buy our battery, we have the best battery. So depending on who you talk to, they're testing their batteries differently to tell a different story. So what Nextracker and ITP are both doing that they have in common that is super valuable is they're just saying, let's define a demand profile, one demand profile that is relevant to our industry, to our application. Let's define that, and let's put all the battery manufacturers against each other and test to that profile and just see which degrades the fastest or the slowest, and also how much does it cost to install that system that meets that profile or doesn't meet that profile. So yeah, that to me is the critical step that until recently nobody had really taken, just defining a profile and testing batteries across technologies, testing them all the same, apples to apples. Seems so straightforward, but anyway. And then there is private data out there. I think DNVGL, a shout out to them. Those guys know their batteries and they're learning more every day. I work very closely at SepiSolar. We work closely with them. There are other private data sets, if you will, or confidential data sets, but you might have to pay for those.
All right, we've got a few more questions. One is from Ben, who asks, can storage be used alongside a PV generator in virtual net metering applications, e.g., for example, with net metering with PG&E territory, in order to reduce demand peaks on remote benefiting accounts?
Right. Yeah. So the question is, just to maybe simplify it, is how does storage work with virtual net metering, or even, I'll just expand a little, even aggregate net metering? For those of you in solar, you know virtual and aggregate net metering is basically just slightly more creative ways of billing customers and utilities for solar generation. I won't dive into the detail of how NEMA and NEMV work. Unless I get another question on it, I'll happy to deep dive there. But the simple answer, how does storage fit with NEMV and NEMA, for those of you who know how those policies work? Unfortunately, right now, there is no policy. There are no policies for NEMV and NEMA for storage, at least that haven't been decided on by the CPUC. Utilities may be offering one-offs. I know there are PFMs, or petition filing modifications, that have been filed by industry, like I believe CALSA, California Solar and Storage Alliance, that have filed petitions to get this into the NEM tariff to allow batteries to reap the benefits of NEMD and NEMA. I do believe they are allowing it, but it is not a very well-defined process. The utilities are still figuring out, industry is still figuring out how to treat these systems and trying to understand. The rules change, and there's a lot of variability because depending on whether the battery charges from the grid or not, will take it down one of two very different tracks. Because of compliance with net energy metering, NEM. And then of course, not to mention the engineering issues that get attached to that, like reverse protection relays and complex metering schemes. Yeah, but as of right now, batteries themselves do not clearly apply to NEMD and NEMA. However, we do see, in the tariff, it's not clearly delineated for storage or allocated for storage. But in real life, we do see where storage does add value by not necessarily demand reduction, but in shifting kilowatt hours. Because the utilities, at least for example on NEMA, with NEMD it's different because you actually allocate the energy coming out of the system for specific meters, and any surplus gets redistributed. But for NEMA, you don't actually get specific on the allocation, so the rules are the utilities actually just take the total output of the system, and once you fill up the meter you're connected to, then they start allocating them to the aggregated net meters, and storage can move energy around, and utilities don't necessarily see it. So it's unclear right now whether that's a violation or whether it's allowed and whether it complies with RPS guidelines, and it depends if it's charged from the grid or not. So to be safe, I would say don't assume batteries are going to comply. I would file your interconnection agreement and first include the storage there, show that you're doing NEMD or NEMA, see what kind of issues pop up there, and try to get through the process with as much common sense and information that you can share the utility as possible to get that through.
All right. And Ben has one more follow-up question, which is, what is the unit-based cost for battery O&M?
That's a tougher question. It depends on technology. So the question is what is the cost of O&M, like a per unit cost, and that's going to be that's pricing ranges, I'll just say on average, anywhere from maybe 1.5% per year of CapEx to, it could be 5% or 10% per year of CapEx if you're replacing batteries all the time because you extended your depth of discharge range. I've heard of batteries failing in the first 3 months due to excessive degradation because they cycled them with a way too high depth of discharge way too frequently, and now they have to build into their operating costs the replacement or augmentation of those batteries a lot faster than they originally expected. So if you do it right, it should be between 1 and 2.5%-ish. So let's just say 1 and 3%-ish. If you don't do it right, you can imagine it goes up from there to almost any number.
We're at 11:55, so that pretty much took up the hour like we thought. But if you do have questions, we can always answer your questions at blogs@SepiSolar.com. That'll go straight to us, and we can get back to you that way. But once again, we are going to be doing this every month, and we're trying to set up a live session also at Intersolar. And we will be sending people a link to recording of this meeting so that you could listen to it again and share it also with people who might be interested in the same information. So thanks for joining our first one. Whoop, Mark has one last one. Not a question, but just wanted to thank you for this and say hi. Oh, well, hi, Mark. Thanks very much.
Thanks, Mark.
Yeah. Josh, any other final thoughts?
Other than, thank you for everyone who joined. By all means, if you didn't get to ask a question or something pops in your head after leaving this seminar and you just want to bounce it off of us, by all means, feel free to email us, reach out. We love answering these questions. We love getting into the weeds and the details. We learn a lot every time we do it. Leverage us. We're a wealth of knowledge and experience, and we like to share.